I've got somewhere.
The wax cylinder runs out or something.
Yes, my passport stamped on the M62 coming down. I did come over from Manchester this time. I was just reading so there was a bit of fuss made with the relatives, and the relatives said, "Hey, no, look, I missed the E off. Oh, yeah, sorry about that. We'll do it." So they gave me the right bollocking, and he went along and he corrected him, put the E on it, and it then said, "E, she was thin." So I would mention before, you might have heard, I'm in the programme. Very unexpectedly this year, I managed to move house. Not the one I live in Manchester, but the one I live in Cumbria. We've got a little. Here we go. Well, this little sort of terrace, half a large house. It's just 2 up, 2 down. Very pretty stone-built thing, and that was it. Well, it was a corner of it, and we've got some big things in the garden, and there's my wife stood behind me. There was a little thing in the garden, and she's been looking at houses for about the last 12 years, basically. It's a hobby, We knew that Van Nistelrooy was leaving Arsenal long before he announced it, because, as my wife says, well, he's put his house up on the market. I've looked round at it. So he's leaving Arsenal, so he's probably coming up to Manchester. But she's not been very well. She's got this ME, basically, and finding the stairs in that rather trying, and the bathroom is actually downstairs behind the kitchen. The bedroom, that's quite a walk, and she's thinking of retiring anyway, because it's a little bit much for her working, and I've been retired. So last June, basically, we saw this house on the market, which was a mere 60 yards from that house, so it's not very far away, and we managed to cobble together some money by cashing in lots of pensions, which accumulate over the years, with about 5,000 in this pension, 6,000 in that pension, bugger all in all of them, because they kept changing the pension providers. Cashed all those in and managed to sort of, I don't know how quite, but swap this little house for a largish bungalow, which doesn't have many stairs. It does have actually an upstairs bit on there, and the plan is for us to move in there permanently sometime over the summer this year, if we can sell our house. We were quite fortunate with that house. We put it on the market. It appeared on the website on Thursday. We had 3 viewers over the weekend, and we got an offer on Monday, and that was it. So that was quite good. Still, the solicitors managed to drag it out for 3 months. We had a cash buyer for this house, and therefore we could buy the other house for cash, and the woman that was in that was moving into sheltered accommodation. So it was a very short chain, but they managed to drag it out. So last there are lots of boxes there that we managed to. I had a little bedroom, back bedroom with all my electronic stuff, and I managed to fit it into an area about 5 times as much, and it's still a mess. But there were some boxes going in. That's the house from the garden. It's on the top of a sort of, I wouldn't say cliff, but it drops down to the main road, and behind me would be a 30-foot drop, and that 30-foot drop is at sea level. And so because you're within a quarter of a mile of a floodplain, they were worried about this place flooding. It's a hell of a flood if you go to that.
30 foot. Yeah.
But I mean, even during the floods we had in Cumbria, we were actually cut off living there. We got about half an inch of water on this roundabout. It was 40 foot down from there. Anyway, that's sticking my head out of the dormer window on the left side, looking at the park. So that's quite nice. And then on about a fortnight ago, when it snowed, I stood there and took a picture back at the house, and that was there.
Wow.
So that's the house at the dormer. We've got a few houses at the back, and this big sort of drop before you get down to sort of ground level, as I think Graham would have said. So that's taken a lot of energy moving, and it's been quite busy really from June. We moved in October, and then I had something else to do, which I'll tell you about in a minute. So there we go. That's the house. That's the view out of the dining room, out the lounge window. Get a nice view of sunrise. Incidentally, this is interesting. This is the Wilkinson Monument. Wilkinson was a local iron magnate, as it were, and he was one of the early proponents of cast iron, and he'd have everything cast iron. And this was a monument he made for himself to go outside his house, his large house, way back there. And when he died and he sold the house with covenants that this monument had to stay in the garden, the owner said, "I'm not having that bloody thing in the garden." They moved it. So it looks like a war memorial. But it's an obelisk, and it's actually made out of cast iron. And you might like this. It's solid cast iron, and it recently got refurbished. And Health and Safety insisted that on the top, that you can see the little book on there, is a lightning conductor, in case it got struck by lightning. It's cast iron. It's set into the ground, for God's sake. It's the best lightning conductor around. Piddling little thing with 4 spikes in it. It's not going to do anything with it.
Whereabouts is this mine?
Lindale.
Oh, right.
Lindale, just before Grange over Sands in Cumbria. And incidentally, if you stand in the kitchen and watch the sunrise at the equinox, at the solstice, the winter solstice, the sun rises right up that monument. Stand in the living room, it doesn't. But if you stand in the kitchen, it does. So we're quite pleased with that. And I'm still trying to get to grips with my bit, which is upstairs. We had some flood. You can read that from there. Probably can't. We had some floods in November before the ones that hit the news. And if I zoom in there, see what it says. Overflow cap.
Yeah, very close. Yeah.
Which I thought was quite funny. That particular flood didn't flood the Swan, but the ones we had in beginning of December did, and the Swan is completely gutted again. It got done about 8-9 years ago, and my in-laws went round when they'd refurbished it, and they'd refurbished it with all these bleached lime solid furniture. And my mother-in-law was saying, "Oh, it's a shame, they could only afford this very old and tattered furniture." No, it's meant to be like that. No, it's not. No. That's all they could afford. It's a shame of them. Yeah. So there we go. And the other two pictures here, you often heard me talk about Alec, and not so much Graham, my youngest lad, but Graham is at the moment in Australia. He left in September to do some travelling with his girlfriend, and they bought motorbikes in Vietnam and drove all the way up Vietnam and then across to Laos, and then down into Malaysia and Thailand, and eventually last weekend took a flight to Perth in Australia, and they plan to be in Australia for 6 months or so doing actual work, whereas what they were doing before seemed to be generally getting drunk and looking at some absolutely stunning scenery. This is the two of them on this Australia Day, which was, as I said, last week. Goodness knows how he managed. She's 6'2", and he's my height, 5'7", and she wears high heels. You know, but it's quite stunning, really. And they've gone to a place to work in a bar, which is there. It's in Nabling, which apparently is miles from anywhere, doesn't have any Wi-Fi, and has a town population of 273. So it's 275 now that they've got. That's the only pub in town, and it's a community pub that they've... so I imagine they sort of rolled up and said, is there any bar work there? Oh, English idiots, they'll stick them off there. So they've gone off there for a bit. How long will they stop there? Okay, so that's the domestic thing. So this, from probably the middle of this year, I will be coming down from Cumbria. If I come, when I come to come and see you. Okay. Now then, let's have a look at this for a start. A lot of the projects I've got at the moment are going to publications and books and stuff like that. But this is one that I've been wanting to do for a long time. In fact, I had a go at doing it a long time ago with LEDs. And basically, it's what I call a geek clock. It's a clock that not many people can tell the time of. And there are two ways of telling the time, in case you're not quite as up to it in one method, you can use the other. And it was actually set on British summertime, and I put the adjustments in this afternoon, and then the whole thing wouldn't bloody work. I mean, what had happened is there was a parameter in the powered read-only memory that wasn't being set in my program, that got set by accident when I first made it, so I forgot about it. Anyway, that got solved, and I did it. And this tells the time by displaying on. Look at the bottom bit at first. And what I'll do is, when we have the break, I'll leave this on in the other demo so you can come and have a good look at it. But we'll turn it on. There we go. And it should. Some lights. We should have a resistor.
Is that a glowing thing?
Yeah,
oh, there we
coming.
go.
No, it's coming.
It's doing any difference.
There you go.
All right.
So the bottom there, I don't know if you can see, is a resistor that consists of 4 bands, and those bands tell you the time. If you read that as a resistor colour code, then you can see that is
2014.
20. Yeah, 20. 2 for red, black for 0, 1 for brown, 4 for yellow. That's 2014, which is, if you look at the computer, is exactly what the time is. So that gives you 2014, and in the middle there are 2 little square blocks which blink the colours, and those are the seconds. So those count down on the seconds. So that's the time in resistor colour code. Now then, if you're not quite a geek enough to do resistors, then it also tells you the time in words. Now, have you noticed how technology promises to be helpful? It promises to make your life easier, and it promises to make everything simple and straightforward. And what it actually does is make things a lot more complicated. Okay? Now, the purpose of this clock is to make it difficult. Difficult to read the time, awkward to get the time. And unlike most modern technology, it delivers on that promise. And what we've got on the top is what, if you're fond of Six Music in the morning, the breakfast programme, there's a DJ called Sean Keaveney, who's also a comic, and he does what he calls rubbish time checks. And this gives a rubbish time check in words. You'll see the time is is 10 to 26 minutes past 8.
So 16 past 8.
Yes. 10 to 26 minutes past 8, which, if you work it out, is 16 minutes past 8.
Yeah, that middle text is a little bit too small.
It is for that distance. It now changed to 24 minutes to 9.
Yeah.
Yeah?
That's a bit longer to work out.
Bit of mental arithmetic, and you can work out the time. Okay? But they don't make it easy for you. You've got to work for it. Why should it make it easy? It's promising. It's promising to not deliver. There was one lad at the Maker Fair he had a resistor colour codes tattooed up his arm. And he got hold of that and stuck it out on the end of his hand and took a selfie picture and posted it. Looks my sort of thing. As I said, I've been wanting to make that for ages, and I did try making it with LEDs, and I did build a clock and a RGB LED displays, but it don't work properly with LEDs. Very difficult to get brown and to differentiate between orange and yellow with RGB LEDs, and black is a bugger.
Need a big disco light for that, don't you?
No, what happens is you reverse the current and it sucks light in. You see, that was the theory, but never quite worked. And the other thing is that the colours depend on the background that the colour is being shown against as to what it is. So that's why, and really, I could only get it working with that sort of display. Anyway, I think it's quite a nice display. This is the Perspex top is a pencil tub from is it Moji, the Japanese stationery, and they produce it's quite a nice effect, and that's a gratuitous, not for publication project at the moment. Now, last time I was here, I was talking about the Raspberry Pi for Dummies book, Raspberry Pi Projects for Dummies book. It wasn't published at that time when I gave you the last talk. We were all sat around waiting for one of the co-authors, to do his 4 chapters. And we waited, and he disappeared, and nobody knew where he wanted to do. He wouldn't answer emails. And so in the end I said, sod it then, I'll write the extra 4 chapters, which was this time last year. So I had to produce 4 chapters in some ridiculous time, like 6 weeks. This is finally the book, and this book came out, it sort of dribbled out. It was first out in June, but didn't make it over here in paper form until about August. So this has been out since August. And there are some projects in here that obviously I didn't tell you about last time because I hadn't written them. I didn't know I was going to write them. And there is also, which I don't think I said, 3 chapters on Riscos. So there's 3 chapters on running, exploring Riscos, part 2 of that. So what I thought I'd do is go through a few of the projects in that chapter. I did show you the glitter jars last year, didn't I? Which was the glitter ball with a camera on the end of it. So I'll not go through that. I can't remember if I showed you the dice game.
Don't think so.
The dice game. I don't even remember. One year I brought a box with a dice on it, and it was like a game of NIM. You had to reduce this heap to zero by actually picking the dice up and rotating it and placing it down, and had sensors on magnetic dots. And somebody said at a maker fair, it would be good if the computer could move the dice itself. So I've been thinking of how on earth you could do that for a long time, and I finally got the opportunity to do it in this book, sort of halfway, in that it's a Lego device, and the Lego device takes the dice, scans it to see what colours, or to see what the dice, how the dice is orientated, then rotates the dice and throws it down on the move that it's going to make. So it's just like tosses the dice at the move it's going to make. And it does the same job. I've got a video here of it doing that. I would have, but that's not the video, is it? I'll just give you that was the original dice game, with the magnetic dots on the end. This is one. Here comes the not paying attention. Just setting up the dice, it decides what to throw. You can see the display at the top echoes what the dice is actually showing. These are the heaps, which is 3 piles of money, go down at whatever rate. So, only a 260 quid Lego Mindstorm set and a Raspberry Pi, and you can do movies like that.
So what's that all written in then, like?
That's written in Python.
That's in Python.
And a lot of the computation goes on in the Lego brick.
Right.
Right, so the Lego brick has commands that say rotate, report back what colour it is, flip the dice over, and then the main software makes the decisions based on that and drives it, basically. Which sounds straightforward. It is when you get it all working. You know, when it all works, it's quite straightforward. What I did with let me just give you a quick run through some of the figures in the RISC-OS chapters. I was trying to illustrate that RISC-OS file names start with pling. And I thought, that's good, I'll get a road sign. And that's the road sign just before the Hard Knot Pass in Cumbria. And I was busy taking a picture of the sign, and this cyclist came past. And he gave me a really weird look and got off. So I said, I'm writing a book about an operating system whose all the files begin with pling. He said, oh, right. Bloody steep that, I know. I said, I know, I've driven it. It was quite funny. We met someone in Ambleside in a great big camper van, and they said, we're going to drive over here. They're New Zealand, and they said, no, you're not. I said, you can turn around now, or you can turn around when you get there, but you're not going over in that. One of the favourite signs in Cumbria now is the sign that says, do not follow sat-nav. They're all over the place.
Yeah.
Hard Knot is seriously intimidating.
It is, yes.
Seriously.
I once did it in a taxi, was in a hurry, which was really stand on his brakes. He'd driven all the way from Whitehaven because we'd overreached ourselves and got to the pub at Boots, and it was very late, and we were very knackered, so let's get a taxi back. The only time we've ever done that. Let's get a taxi back. But he came from Whitehaven, it took him like 25 minutes, and then drove over the pass and down the bottom. That was a thrilling experience. the Bolton Towers races, roller coaster's got nothing. That might be familiar to you. That's running on the Raspberry Pi, as you can tell from the Raspberry at the bottom, and it's the standard sort of desktop that you get in. So I was explaining about the anatomy of a RISC-OS window, which you all know, but nobody else does. There's a couple of examples with paint working. There's a little example where I got one of those programs with a string, you know, there's a thing on a string and you whiz it down. And I made a little modification so that it didn't stay inside the window and it didn't rub itself out when it had gone, so you scribble all over the window. Which is a rather artistic way of scribbling down. And then I did a program for generating sprites from other art work by reflecting the sprites in symmetry, fourfold symmetry, with a positive line there, an upper part and a lower part, and a negative line, the lower part and upper part, so that there were variations that you could pull on these sprites. You could make reflections with that sort of symmetry, that sort of symmetry, that sort of symmetry, using the upper part or the lower part, the upper part of that. And when you do that, you take a picture of a corner of the car, which is a stock artworked picture, and then produce these symmetrical distortions and patterns, kaleidoscopic patterns from it. So that was see, it says 8NL, so that's eightfold symmetry, the negative slope of the line for the left, take the left hand side. And this is eightfold symmetry, negative, taking it, not left, lower, taking the upper, and the same there. 8 positive lower, 8 positive upper, and that's the original image. So those are all those 4 symmetrical, those 4 asymmetricals and the 4-fold symmetry from that original bit of the image. And the program, so it's in there, explains how to write a program, and that's what the program does. You know, a typing thing, like the old days. And then I did the transistor tester, which hadn't been Acorn user before, but it's a jolly useful project, and that's the schematic of it. And basically it consists of lots of switches and a transistor, and you switched in where the 5 volts was going, where the ground was going, what was going into the base and what was going into the collector. And by trying every possible combination and making all the measurements, you could tell which way around you'd put that transistor in, whether the transistor is an NPN or PNP, and what the gain is by just looking at the values. There's the physical thing connected. It's an I2C protocol, and there's the picture of the display. There's the icon bar, and it's telling you that on pin 1 you've connected the emitter, pin 2 the base, pin 3 the collector, the gain's 304, and it's a PNP. And you click the test button and it does it all again. So that's that was the RISCOS bit. I had to lose, sadly, a project in that chapter. I had to get rid of a couple of chapters, and that was one of them. And one of them was it's here somewhere. I'll find out. It was a digital voltmeter, and the digital voltmeter I managed, by dint of connecting the ground to an earth, a real earth, managed to measure between plus or minus 1.999 volts and get 0.2 of a millivolt stable reading from it, which was quite good. Before I connected the ground, it was all over the place. But I managed to do that. But I really had an awful time with the editor of this book, who was, how can one put it politely, complete cretin.
Was this the bloke you spoke to about last time?
No, it's another one.
Another one.
There was a selection.
The bloke I spoke to before was a technical editor. This was an editor who I think quite honestly, she's got a bit of a mental illness, and it's a little sort of Asperger's, and she would say sort of stupid things like, "How do you get 3 from 1? It's binary." What's binary? You're editing a computer book. Tell me. And she would edit out all sorts of anything. I talked about the Nyquist criteria being produced by a bloke called George Criteria. I think this is an attempt at humour on the behalf of the author. This could confuse readers, so we'll better remove it. Americans, absolutely.
Okay.
You know,
Said the A
You
word.
just said that at the beginning, Mike. didn't you?
yeah, Americans. Although I have had good editing experiences with Lego. It was just this one, but it's got really, in fact, it was so bad at one stage in the editing process. I said to my editor, "Look, if you don't stop this woman, I'm going to refuse to have this book published. I'm going to just completely withdraw it." I was within that far of doing it. So anyway, it finally come through. But I'm not enthusiastically promoting this because bits of it aren't quite I'd like it to be.
Did the Nyquist joke make it?
No. But I got you another book.
Wasn't filtered out.
It was. It wasn't fast enough. Another one that didn't make it was a Lego invention called a Polar Bot, and it drew. It was like a drawing robot, and I spent a long time working on this. And it never really worked properly. And the reason it didn't work properly is that we couldn't get the right degree of control that the motors were capable of. And I spent like 50, 60 quid on a specialist Raspberry Pi controller for Lego, and it was rubbish. And it just wouldn't, you know, you'd set it at a certain angle and it wouldn't go there. You set it at that angle and back and there and back, and it would drift off. And I've tried umpteen software things, and I literally spent about 4 months on this project. And in the end, when she said, it's too long, we'll have to lose something, I said, well, let's lose this. I was reasonably happy with losing that. But before it sort of went to bed, I did make a sort of a movie of it drawing a spiral, and in order to make it do it at some sort of decent speed, I speeded the video up about 4 times. But there's the so this is where I've speeded it up.
So effectively, it's trying to be an XY plotter.
Trying to be an XY plotter, but it's got a polar arm,
Yeah.
which gives you the. There you go. So that arm sticks out, so that's the radius arm, and then the other one does an angle, and that gives you. Sure, it's on the little thing. There are umpteen problems with it, not the least of which was the torque that way, as it dragged through the paper, and that distorted where the nib was, the pen nib was. And as I say, it didn't help that the motors weren't going the right angle. And if you're ever trying to work on something like that, you know, one software error and this thing rotates around and smashes itself into pieces because it goes completely around the bend. This thing here lifts the pen mechanism at the front end, but again, you won't see that because it didn't work well enough, really.
Presumably, real XY plotters are a bit chunkier motors, do
Yeah, well, they've not got that
It's not-
polar coordinate things, and they've got normally servo motors.
Yeah.
And use it on an X. The motor works on XY.
Yes.
Because if you think about it, the amount of maths you've got to do to make that a straight line, it's not just a matter of working out the coordinates of the start point of the line, the end point of the line, and joining the two up together, because that's in polar space. So you've then got to take the start point and the end point of the line and subdivide it into lots and lots and lots of lines, and then draw between each one of those lots and lots and lots of lines. And that's why the whole thing was very, very slow. It would draw straightish lines, but it would distort on one side and not on the other. I think Lego is not the right thing to make that out of.
No.
But nevertheless, that was. Yeah, that was the. That was the picture there. There's some spreadsheets with some numbers and calibrations. And the software was quite considerable. One of the things I did make was, in the new chapter, was my source bottle. Now, never quite done it this well before, but basically, you take the sauce bottle and basically I got this big sauce bottle from the Maker Faire barbecue in Brighton, and I said to the bloke behind the barbecue at the end of the night, "Can I have that sauce bottle?" And he says, "It's empty, what do you want it for?" He says, "I want to make a game with it." He says, "How could I refuse you?" How could I refuse? So what I did was made photographed the sauce bottle and cut it up into sections. So there it is with the plastic on, and then I got rid of the plastic and just left the labels, and I got rid of everything else on the outside and made these masks. And I've got one somewhere with a wire in it. You see, so that's the original fit picture, had a wire in it. And then I took the wire out, so that's the same picture with the wire out. Photoshop, messing about. And then, by dint of putting these layers in front, drawing them, I could draw a large piece of transparent rectangle for the source, which had a little bit of transparency with it. And by altering the size of this rectangle, I could control what appeared to be the amount that the bottle was filled by. Okay, so that really is a rectangle that size masked out.
Yes.
Okay. The bottle itself has a tilt switch in it. So the idea is that you shake the bottle. Each click subtracts a little bit from the sauce. The sauce empties, and it's a race to find out who can bugger the shoulder up first. So
It's a
this
squeezy bottle.
squeeze.
Oh, it is, yeah.
It is a little bit like that.
But doesn't lag behind after ketchup.
Well, there's a phrase by that American poet Ogden Nash that goes, "Squeeze, oh squeeze the sauce bottle. None will come and then a lottle. So, with a very minimal amount of electronics, which is a switch, basically, which was attached to the Raspberry Pi by 2 pins, a ground and an input pin, bit of clever graphics, a little bit of software, you could get this game where you empty the bottle. And that was one of the new chapters I had to do. I actually put it, when I was down to write the whole book, that was one of the chapters I was going to do, was a source bottle. And in the end, I ended up doing it myself. So, I've got somewhere. Somewhere a movie of it. There we go. And that last little clip was a lad at the Maker Fair last year. Absolutely went down the stroke. He loved it. Kids love doing stuff like that. I had a special sort of tube that the wire went in so that they would rip it out. So you put your waves on the wire and then it would completely rip out anything. And I had sponges and green scrubbers, pan scrubbers that clamped to the desk to try and absorb all this energy. And they only managed to rip it apart once. So that was quite good. Because one of the problems of shows are piles of feral children on a Sunday running round pressing everything in sight very hard. Because if you don't press it very hard, it doesn't work. And the idea was to sort of wreak my revenge and get them to put the shop out. And they never do. So it's only for old men. So that was it. The other thing I did on here was to make a project which I call the Light Fantastic, which was basically if I show you just go through the figures for that chapter. Basically, it's that. It was a 4x4 grid of illuminated LEDs, and each LED was one of these NeoPixels, these WS2812Bs, which are completely fantastic LEDs. They have the controller in them, so you just chain them together and you just feed a nicely timed serial signal, wallop, and they all display what they've done. And the controls are quite easy. So that was the finished one. That's basically what it did. These LEDs come in various forms, surface mount or conventional through-hole devices, and that's a circuit for through-hole device. You put a 0.1 capacitor on each one, and there's a power and ground, and then a data in and a data out, and you just chain it along like that. And I was a bit hacky. That was the keyboard, and what I did is I took an existing 4x4 printed circuit board, which was designed for just conventional RGB LEDs, and I hacked it out with a scalpel, and there is showing the tracks that you had to cut, and then when you cut those, the scalpel, cut them over, and then you put the components in, and those were the LEDs that that printed circuit board was never designed to use. And that surrounding thing is the meshes that a carbon plug comes down and shuts out. So those are the things go in the middle of the hook. And there I've wired it up. You can see how they're going in more of a snake arrangement through it, and these are some diodes that we put in, and then wired the thing up to get a repurposed keyboard. And that was the practical aspect. That was making the ribbon cable. I still don't know where that vice is after the move. I'm still looking for that.
Over it one day.
I will, yes, literally. There's a side I made from printed circuit boards, and then a little mesh top, and glued it all together, and photographs there. These are ones that didn't make it in the book. That's the wiring of the drivers. You get more of an idea of what the thing's like when you do that.
So is the plastic grid you showed, is that pre-formed or does it come with a box? Or?
No, I made it out
Oh,
of
made it.
plastic.
So it wasn't a 3D printer? was it?
No. No, I've got a 3D printer that works. That's the without side, and then these are the sort of results that you can get. Although it's difficult to photograph coloured LEDs,
Yeah.
it's not the easiest of things. But those are the sort of things you can do. And so one of the chapters was about making that. Another of the chapters was about 4 or 5 games that you could make with that. One of them, a video of, which is a politically correct game. It's called Good Neighbours. You've got to move the colours so that no 2 colours are next to one another. Okay, so you don't get ghettos. So they're all nice and integrated. You see what we do? And the way you move the buttons, you press the button of the colour you want to move. You then, which then flashes, and then you click the one that surrounds it, and it swaps place with it. So that's the idea of that one. Another game was Pelmanism. They're all black. You click one colour and you try to click the one that had the matching colour in it, and they all flashed when they were right. There was a Minesweeper type game where you pressed the button and it would tell you how many along and up you were from the target, and it told you in resistor colour-coded colours. So, so if you're 3 away from it, it could be 3 up or 2, 1 along and 2 up,
Right.
2 along and 1 up or whatever, but you got an orange,
Yeah.
basically, resistor colour. So, there's about 4 or 5 games. And there was one had to be ditched, so that one that was ditched is on the website now for people to look at and play about with. How are you doing for time? We're nearly all.
I'm nearly finished, but I know Terry started after
What?
me, so
Well,
if you want to have a break, have a break.
well,
We've
no,
got 18 minutes on this.
Oh.
Right, yeah.
Well, I'll show you this one over here, and then we'll have a break and I'll come back
Okay.
to the ones that the other ones. But basically, because in the break you can have a closer look at these things.
Yeah.
Okay. It runs ahead of what I was going to say, but what I've started doing at the moment is writing articles for the Magpie magazine. I got asked to do it about this time last year, and we had a bit of a kerfuffle about rights to reprint and etc. How that would work out. Anyway, eventually it got sorted out, and I started to write for it. This over here is what I've done for the March issue. So I only submitted the copy for that on Monday. I only finished it on Sunday. But I've been working quite a bit on it, and it's a halfway stage. What's happened is they produced a new Raspberry Pi called a Zero. I don't know if you've come across this one. And that was on the front of the Magpie, which really was sort of, it sold out within the day, basically. I didn't get one, despite I drove in the berry. No, we're not going to, never heard of it. So the editor said, would you like one? So I said, yeah, got one, nobody's got, these things are going like hen's teeth at the minute. And he said, do you want one? So I said, yeah, all right, I'll have one of those. So he said, will you do a project on it? I said, yeah, I'll do a project on it. You give us one. So it's a bit of a funny thing for a project, because it's a Linux machine. So you've got to boot the thing up. So the thing's got to boot up, and it's got to also, you've got to power it down. You've got to, say, shut down now, and then you've got to wait about 15 seconds while the whole thing sort of shuts. You plug out, but sometimes pulling the plug out buggers up the SD card.
Yeah.
So you're going to be careful with these things. So I said, well, I'll do a magic mirror type thing, and then in the same issue there was a magic mirror, which is not quite what I've done here. It was basically, it was a Raspberry Pi in front of the mirror with a monitor, so it just showed a website, the weather forecast, or what have you. But this is part of my magic mirror, which is basically pretty LEDs. So if we plug that in there now, it boots. It takes about a minute to boot. So we'll just wait for that to come up. And are we on yet? Right, what we've got here is we've got an infrared distance sensor at the bottom, and the idea is that you move into it and it triggers different light displays. And so we'll try and get this one out here. There you go, that's the first. Now, that's a little bit, I don't know if you can see from here, that's just a sort of like a radar scan going round. But you might be able to see that it's a circle of RGB LEDs, and inside the circle is a mirror, which is actually a mirror, it's a CD. So you get the diffraction patterns from the pictures as well as the reflection. This is like two-way mirror glass on the front end. If you go closer, the display changes to a white display. You can see it wiping through the primary colours of white. And if you look when it's on white closely, you can see it's breaking down into the spectrum of the lights. There's no A to D converter on the Raspberry Pi, so this I've had to make a little 4-level flash converter, and again that's part of the project. And then we get a bit closer than that, we'll get that, which is more of a sort of well, it's multicolored flash. You might notice, back off there, that these LEDs around this drum are arranged in a spiral that go in, rather than just a great circle. So there's a degree of depth in there. You can probably see when you're closer. And then if we go closer still, we'll get the final. There we go. Display, which is then a more subtle, slower fade through all the colours that it's capable of producing. Oops. There we go. As I said, this is part 1 of the magic mirror. Part 2 is going to have a rubbish time check in the corner. Designed to wake you up in the morning to say, what time is it? Oh, well, am I late or not? To get your brain going. So that rubbish time check has been converted from C into Python. And that wasn't easy. Spaces, indentation. So, we'll take a break there, and welcome to go and have a look at the rubbish time check. Stick around in front, look at the patterns. I'll be develop the code on the B+ Raspberry Pi, and then just slip out the SD card, and then plug it in the 0, and it runs the program that you've worked on. You can tell it. That's this for you. These are some pictures of that frame. This is the back. There's a really early video, and that's running off an Arduino, but don't tell you. And that's before I had any reflections inside the box.
So is it inside just cardboard, or is that plastic?
It's cardboard.
Cardboard.
That was a violet chocolate box from Christmas.
Right for Christmas.
Well, it's not one.
What with the CD then? With one of these you get free magazine.
That was a Norton semantics virus checker, circa 1995.
Yeah. Trends that are not much used now. Yeah.
Not a lot. Not a lot. So I think I've got. I wrapped something down. I made this block so that I wouldn't crush it in the drill. I only drill it holes of cardboard. You can still crush it in the drill. Pushed it down, put this copper tape on it, and then cut away the copper tape, and then glued these surface mount LEDs on it on the side.
So that sort of gives it the depth thing, does it?
That's the spiral.
Spiral, yeah.
That's the spiral down. I didn't know how well it was going to work, but I think it works fine. It's different. It's not just a circuit. And then that's the interface board. The start of that, and then I wired it up basically by hand with some little surface mount capacitors in front. They are those little things. Power and ground, and then in and out.
That's pretty fine work, isn't it, doing that?
It is, especially when your hands go like that. The older you get, the more your hand goes like that.
Makes you wonder how surgeons get on, doesn't it, really? they practice by looking under a microscope,
Yeah.
apparently.
Well, I had my head visor on.
Right.
But the surgeon that I took to make an acorn atom, which tells you how long ago it is, we did a keyboard, and he had a class that did them, and I got 20 keyboards working. The acorn, that was the Achilles heel of the atoms, the keyboard was a bugger. And this surgeon who was on the course said to me, "You've got to be very precise in your job, haven't you?" So I said,
You lost.
I said, "Well, you've got to be very precise in your job, surely." He says, "No, you stitch up." No.
No, you're not saying it.
As long as you're not left the scissors in.
Do you really?
You don't really.
Rabbit hole in.
Was he a keyhole surgeon?
That's it, I was just taking that the other
What the
day.
heck does that say?
Art says electronic construction. No, electronic constructor.
Yeah,
Oh, right.
that was a
Does no one else read Russian? Yeah.
a Russian electronics set
Yeah.
that we bought in 1991 when we went to St. Petersburg. It cost 75p. It was done. The exchange rate, that it was communism was still, it was just about to fall as communism,
Yes.
but it was teetering.
Yes.
And the exchange rate was £1 to pound outside the country. When you got inside the country, you could exchange it for 10 rubles for the pound. If you went and showed a pound note on the streets, you could exchange it for 100 rubles per pound. So that's the exchange rate of 100 rubles per pound instead of that.
Yeah.
I took the kids into the toy shop in St. Petersburg, and I just said to them, "You can have anything you like."
Because you'll never be able to spend it.
Never be able to say it again. So
Are they still using abacuses on the tills? and things?
they weren't, but they were the old sort of Jewish typewriter things, you know.
In restaurants, when I was in the 1980s, they were still using the little handheld abacuses
Oh, right,
in
yeah.
restaurants and things.
Yeah.
And very skillful they were.
They have the same queuing system as Argos in the Soviet Union.
Yeah.
It's what brought the Soviet Union to its knees, basically, because you had to. The trick was you had to look at something first, so you had to, which were all displayed in glass cabinets, and you had to get the girl to take it out of the glass cabinet to look at, and then you would say you'd want it, she'd give you a ticket, and then you'd go to another girl and you'd queue up and pay,
Yes.
and then get another ticket. You'd come back to the original girl who would have wrapped it up by then because it took you so long to do it. But getting the girl originally to take out the goods that you wanted to see was tricky. And what you had to do was not how you'd have to do it in the West, is to catch their attention and go, you know, here. But you had to stand there in front of it, head slightly bowed, looking miserable, but saying in body language, "I can fucking stop here all day. You're going to have to get this out, so you might as well do it now." And they come and do it for you. We did have one person that wouldn't show us this book, and it was an illuminated Bible, basically, and it was that by that, and it was gold leaf and it was illuminations, and it was £17.
Good grief.
And we just couldn't bring ourselves to buy it because it was like stealing it.
Stealing,
It just didn't feel right. Plus the fact we had another 4 weeks to get it back in the tent, you know. But even so, so we took out and looked at it and said, "Right, thank you very much." And she said, "Yes, I knew you wouldn't buy You know, but it was for totally a different reason. Right. So that, somebody mentioned that if you didn't know Russian but knew schematic, you could
Yes.
sort of on the forum, and that's why I said, oh, I've got one of those, and, I photographed that on the other day to do it. Which brings me to a little tale of the forum, because I do spend quite a lot of time on the forum, and I do quite like it. And you can have quite we'll get there eventually. You can have quite a laugh sometimes. This was this little story that happened over a case of a couple of days. So, you know, Hugh was not that quick on the forum, but this was really exceptional, I thought. This guy said, today I had a really bad time. I was working with my Arduino and suddenly smoke came out of it and I had to turn it off. I had no idea what happened, but I was using 5 volts to supply it and I fed the Arduino with 5 volts. I also connected it to the USB. Could this burn something? Well, smoke's a good thing. So people said, you know, did you actually short anything out? Is it a genuine Arduino or a clone? It's one of the strange things you should not do with an Arduino. I put up lesson, never wire up anything with the power on. Experience varies directly with equipment ruined. I said, no, I've ruined very little of my life. Plus, it's only experience if he knows what he did wrong.
Yes.
Of course. So he came back and says, thank you for teaching my lesson. I saw many people on Google to say what I did was fine. So I asked you a different thing. I was supplying 5 volts to my Arduino with a VIN pin and connected to the USB. Could that also burn my Arduino? And I said, no, because there's a switch that automatically changes the power source. Can you post a diagram, which is standard? He says, it doesn't look damaged from the outside, except there's a small point on the chip, like a black hole. It doesn't look damaged, but there's a hole in it. There's a black hole in the corner. It's only a pinprick, so I was wondering, could it be this?
Just fill it with a bit of epoxy.
Yeah, that'll be fine,
He then said, this is where it starts to get interesting. What chip, he says, what chip is the chip? Grumpy Mike, the chip is the black square thing in the middle of my Arduino. Funny man. Now, if you want help, what fucking chip are we talking about? It's your choice.
Yeah.
He says, my Arduino Nano, it's the first time he's mentioned that it's an Arduino Nano, only has one chip. It's the square one in the middle of the board. I don't know if you're drunk, but I can only count one chip. Here is the image. So, here was the image that he posted a link to.
That's fair enough.
Not his own that's got the hole
No,
in
no.
it.
Not his own. So, a little bit miffed of being called being drunk. I said, you've a Nano. It's first mention of it here. Sorry, my crystal ball's on the blink, otherwise I might have known that. And he says, I don't know if you're drunk, but I can only count one chip in this image. Well, turn the board over and you will see 2 chips on the other side. Now, with such a crap attitude, you expect them to help you. So I said, turn the board over, LOL. Then this guy posted this YouTube video, and it was a complaint to Asda's customer service department about he just bought a pizza, and this pizza had no topping. He had it upside down.
Sorry, it's our bottoming range.
So someone posted this seal, I think a good line. So I'm having a roll about that. So someone said, a hole is a sure sign of Jim's having catastrophic failure. Anyway, trundled on it, and in the end, yesterday he put, Grumpy Mark, Larry and John, I'd like to thank you for an entertaining, great morning wake-up read. I never laughed so hard in my life. You guys crack me up. Keep up the great work and the entertaining responses. So he took it in the right, spirit. But I think that was quite a nice little tale that he wrote over a couple of days. Turn it over. There's two more of that. He honestly didn't know there were chips on the other side. He says.
No. No spirit of adventure.
Discovery.
Yeah.
Discovery. Oh yeah, I was going to show you that. It's an audio joke.
Very good, yes.
These glasses are crap.
Of course, some of them now may be DSP, so you should really put a
Oh.
shark. You should put a shark in there, shouldn't you?
Yes.
Oh, that was very clever.
You know the joke about why does it take millions and millions of male sperm to fertilise one female egg?
Oh.
Because not one of the both will stop and ask the way.
I thought you said left at the fallopian tubes. Okay. Now, in addition to Raspberry Pi projects, I was also writing a book on audio for the Raspberry Pi. Not for the Raspberry Pi, for the Arduino. Because somebody had said, what do you want like write a book on? And I said, I'd really like to write a book on audio projects. So I submitted a proposal and they accepted it. Mannings were the publishers. And writing the first part of that book really got in the way of writing this one. I was trying to write the book at the same time. Now, Mannings ended up being complete utter arseholes about it. They were worried that nobody could reproduce what I'd done, because I was having these big projects in that had taken me 4 months to make. You know, so there were big projects. There were lots of little projects as well, but there were big projects, and they were worrying about the minimum qualifications for our reader. Yeah, what is the target audience? I said, people who want to make music on the Arduino. Yes, but who are they? What qualifications will they have? What are you expecting them to know? What tools are you expecting? And it just went on like this forever. And after we got back 5 chapters, they'd send the book off for 6 people to independently review the chapters. And the results were mixed, to say the least. Some of them said, fantastic, you feel like he's there every step of the way with you. And somebody else said, he uses a mixture of long and short sentences, which I find jarring. Some Japanese guy who got a PhD and was doing postgrad research in audio said, the main thrust of this book seems to be fun. There seems to be too much fun in this world.
Well, I've none of that.
We have ways of making you not have fun. At one point I put, it was a MIDI program where you pressed a key on the MIDI and it generated 3 other keys to make a chord, to make a triad. And to illustrate what it was, the different sorts of triads, to illustrate the different sorts of triads, I put a note, a little diagram in with a treble clef and the notes. Back from the editor came, Mike, a lot of musicians don't read music, so do we have to put ability to read music in the minimum qualifications for this reader? No. I was doing the automatic harp player, I think, with the CD drive mechanism.
Yes.
And I was explaining what you're looking for in the CD drive mechanisms. And she said, can you put in a picture of the CD mechanisms that aren't suitable?
Sounds like people at work.
Yeah, so I had to insert this diagram in the middle of it with me hutching up all the references to all the other diagrams
Yes, yeah.
in it. Oh, it's quite a lot of work. But I put the caption on that said, Obi-Wan says these aren't the discs you're looking for. She didn't get it, so it stayed in.
Brilliant. It's a great sort of thing. So, yeah.
Anyway, they got thoroughly pissed off with me for not changing everything that they said, you know, that big stuff. And I changed all the little, Americanisms and stuff like that. And in the end, I got that fed up with it. And the book got quite long, and I'd only written a third of it, and it had gone to 200 pages. So we said, let's call it a drawer, eh? And I started writing this. So I left it in the drawer, sent it to Maker Publications, and that's a black hole. You send anything to Maker, it disappears. I've even got the personal CEO of Maker. Email, and I correspond with him, and he passes it on to his editors, and everything disappears. And I've tried over and over again to get something published in Maker, and I can't. It just disappears. And I keep saying, well, you have to do something about this, because, all right, you might not want to publish it, but I'm not a rubbish writer. I have got four. I have got four doing writing a bit. So we decided to call it a day. And then this summer, I got a flyer around from a company called A-Press, and it had a little note on it. These are special offers now. A little note saying A-Press also are looking for authors. So maybe they want half a book.
Yeah.
So I'll send that down. So I sent that down to him, submitted it where it said. And I got 6 out-of-office emails, almost immediately. 3 from people who didn't work there anymore. Anyway, I got one from a real woman, a commissioning editor, who said, funny that, I'm looking for a book on audio.
Yeah.
That sounds very interesting, but I can't talk to you in a minute because I'm going to make a fair. In New York. So I said, okay, if you see Massimo, say hello from me. Anyway, she came back, said, yeah, Massimo says hello back. Which is quite good. Anyway, they said, yeah, we'd like you to finish the book off. I got the email that said that on the day we moved house. We'd like you to have it all done by the end of November because we'd like to catch the Christmas market. So I'm moving house and I have to write half a book, which would take me about 4 or 5 months to do in that period. In the end, I didn't do it for the end of November, but I did it for the second week in December, which I thought was bloody good, given the circumstances. So I then wrote the second half, or the second 2/3 of the book, on sound sampling and digitisation and Fourier transforms and basically generating sounds with an Arduino. The first section had been MIDI and messages and OSC and doing things with OSC. And the second part was things like Dalek voice changer and remember, I don't remember, last year I showed you something that delayed the sound.
Yes.
People sort of dropped apart, and that was in there as well. So I'd done a lot of the work, but I still had to write some work then. So that was the audio book, and
Is that out now?
it is. It came out as an ebook for just before Christmas, and I believe it is a paper book now. I haven't got my copies, or else I'd have bought some with me. But I believe any time now they're going to come through. Not only that, I thought, well, I'll ask Massimo and David Cartillas, the two people that started the Arduino project, if they'd write a forward to me. And they said yes. And then they didn't. Nothing happened. Oh, they've not done it. So anyway, last week I found somebody posted on Twitter. I don't really understand Twitter, but somebody posted my book on Twitter and followed me on it. And there on the cover said, forward by Massimo. David. Is there? Well, on Amazon there's a little thing you can look inside.
Yes.
And it's the forwards to things that,
Yeah.
you know. And there he is. So they actually produced it. They've actually got a forward from both. And one of the things they say is that, despite being called Grumpy Mike, he's the least grumpy geek I've ever met. So, so that was nice. I was quite pleased about it. Quite pleased about that. So I'll just sort of go through. I mean, basically the first chapters. I didn't want to write the first chapter. The first chapter was written on behest of Mannings, who said we need an introduction chapter to sort of get everybody up to speed. So fine, I wrote that, and then later on they said we could do with dropping that introductory chapter. I said, not in your bloody life if you've got me a mate to do it. You know, that was one of the problems. So I think the tale is best told in terms of diagrams. So I go through the various bits of Arduino and how to wire things up and what the symbols were, 7-second displays, how to wire things up, tools, and chapter 2 I look at MIDI and look at the signals that are generated by MIDI, what sort of arrangements you can wire MIDI controllers and mixers, etc., to how to interface MIDI to your Arduino. Outputs, inputs, and pair of them together. There's one I built earlier, and how you can control it. And then chapter 3 is MIDI, when I explain the different sorts of note on, note off controller messages, fairly routine stuff. How you can make the Arduino look like a MIDI controller device ordinarily. And then chapter 4 is where I consider it gets interesting, in that I start doing things with the MIDI. So MIDI arrangements. That's the treble clef I told you about. Do they have to read music? No, they just have to be able to work it out. And this is a project for selecting the chords, physical diagrams. This is an echo, so whatever you play, it echoes it back. This is a more complicated one where you can enable different sorts of echoes and different delays, got a speed control. Same sort of thing with 4 different delays in a circle. And then we've got a MIDI recording system where you start and stop MIDI playing, and of course all the software is there in it. So that's chapter 4. Chapter 5 looks at MIDI instruments, which ways of making, extending the number of input and outputs you've got. That's a cascade multiplexers for huge, great big controls. These are resistive pads that you can press on and you get a change in resistance with them. So there's instruments you can make go ooh by pressing those various ways of wiring it up. Piezoelectric controllers. Look like the spoons, don't
We do, really, yeah.
That's a bendy resistor, so that'll bend through 90 degrees, and it changes its resistance depending on the angle it bends. XY pads, there's a Nintendo Game Boy pressure pad that you can buy for about £2, and they're just glass replacements, and you can use that to work out the XY area. Adding a nunchuck on for air drums, as you go bang in the air, and depending on if you bang there or bang there, you get a different drum.
Yeah.
That's a nunchuck, wiring it up. Things go. This is the distance sensor that I've used for that magic mirror. It's a stylograph. Sorry, this is a spoonophone, and that's made with electric conducting ink. So I made this mask template, and then stippled the conductive ink through it. Took that away, and there's no need for blank notes because the key is set by the crocodile clip going on a list there, and that will set the key, and you can then send that MIDI note from that. The spoon, called a spoonophone. And there's distance sensors of that, which is one of them for a theremin.
Yes.
One's a pitch and the other's volume, and you can wave your hands about in front of that. And it's MIDI, and that's not easy because MIDI's a step note thing, and the theremin's continuous. So what you've got to do is you've got to fix a note near where you want, and then you've got to use the pitch bend to make it continuously variable. No, a clever little bit of software, but it worked. There's driving LED strips in a not dissimilar way to one of the Arduino projects. The project, that's identical. On there. So then we come back from chapter 5 to chapter 6, which is the harp player, which is starting to get complicated. They asked for the hardest chapter first, and this is the chapter I wrote for them, and they nearly went ballistic. What is this? See, you wanted the hardest chapter, and you've just been presented with the hardest chapter with none of the lead up to it. Idiots, idiots. So this is how to make the MIDI control. That one and that one are the drives you're not looking for. Those are the ones I had to choose from. Grief. There was a lot. I spent a good 3 months fishing them out of the skip at work. Because they'd scrap them, they're on old machines, and they just scrap them. Is that scrap? Yeah. It still works though, but it's scrap. Because it's I like it. Sequence. Sticky little limit switches on, arranging the pictures. And then the diagram. They were very keen on annotated diagrams at Manning's, which is why you've got these little handwritten recursive scripts. And I also made this sort of annotated oscilloscope to explain what was going on. If you look at the book, there's a marked contrast because all the first part of the book has these annotated diagrams in, and the second part doesn't, because I hated it. But anyway, the little logic level things, motors, stroking on the stables, what happens, pulses, MIDI interface, power supply, it's the physical gubbins of it, and that's the final project. So again, that was what I would call a big project, as would the Arduinocaster, the guitar that I showed you some years ago, and how it works, and again, annotated diagrams, breaking it down into lumps. Flow diagrams, that sort of thing. So, Chapter 8 talked about OSC and friends. Sort of OSC is open sound control, which is like a network-based version of MIDI, and the something to do with this. Explained about how OSC works and how to use it with a program called PD, Pure Data, and how to use it with Max, which is another graphics-based music program popular with musicians. So those are the, and had an application on the iPad which moved sliders and did things over IC on the Arduino. So now more projects, drawings, and these are, well, the first one's the pendulum that you've seen here, swinging along. Next is these MIDI footsteps, which generates MIDI signals from feet, pressures, and now the old faithful glockenspiel. But because the electronics are a little bit difficult to, the bits are obsolete, so I had to redesign the whole thing, the whole software, so that it didn't rely on monostables and drivers, so I could use a different sort of driver from there and rely on the, apart from that, things the same. And then a servo for hitting stuff with, which is a MIDI beater. Yeah, 10 servos or something, they all arranged to thump things with. So that was the end of the MIDI section. And then the sound section started off by sort of saying, what is sound? I was quite pleased with that picture. At the top is a transverse wave, and the bottom is a representation of the actual sound, air pressure. So the dots are cycles. The dots are pressure, and the high pressure corresponds to high density. I had to write a computer program to draw that before I, and then look at the anatomy of the wave form, building up a square wave. Sorry, all those three waves sound identical to you. The only difference is the difference in phase in the harmonics. But because the harmonics are identical, they will all sound the same. So there's this theory that some people think if the waveform is different, it sounds different. Not always. A lot of the time, but not always. All those sound exactly the same. Making up a squarish wave from several smaller harmonics. That's made with 208 harmonics. But the wave's looking pretty square at that stage. It's not perfect, there's a bit of overshoot on the top, and there's a little bit of, not ideal at the end, but that's it. And then how harmonic content changes with time decay, how to deal this stock price is dropping by 10%, and it's an exponential. But if you do it in terms of decibels, then it's a straight line, and you can predict where that's going to go. So that's the sound wave. And again with square waves, field effect, and finally worked on the DSP, which I'll just go through this one. These are digital filters, and these are used on the Arduino Duo. So we'll move, because there's a lot more processing. And this is a distortion by transfer function. If you have a linear transfer function, what you put in is what you get out. If you change that slope, what you get out is an amplification of what you put in. If you make it smaller, what you get out is smaller than what you put in. So the slope there is a volume control. But you can do other things with the transfer function. For example, if you have a wiggly transfer function, you put in one frequency and you get out twice the frequency from it. And basically, it's all a matter of having a lookup table in memory. So by drawing clever transfer functions, you can get different harmonics from it. So there's something that's a pure seventh harmonic that's coming out of the sine wave. And then this is a Fourier transform display, a spectrum display of audio, where you can put the strips of neopixels down. And I did that, but I only did it as a straight line and sort of marked it off with paper, so I knew they were going down in the right places. But that is a job to do this weekend, is to build that for the projects. Okay. Well, just to finish off, because I'm totally over-prepared, as before, I'm now doing these Magpie projects, and one that I did was a project for a one-dimensional table tennis game. And I called it one-dimensional Pong, and then I thought, oh, that's not the right name, and then I thought of the right name for it. And once I thought of the right name for it, I could do it right as a project. Because I had it at the Maker Faire as a project on Arduino, but once I thought of the right name, I could do it for Raspberry Pi. And the name is String Pong. Which I think you'll agree is the right name. So we've got a big roll of multicoloured LEDs. And we can send them around. And there's a little group of LEDs, and basically you have to hit a switch, foot switch, to bat it back, and you've only got 5 goes to get it, and the nearer the end you get it, the faster back it throws it. And it throws it back, it goes faster, and it will be a different colour, which is great fun. And I'll just show you a video of that happening. The music, by the way, is a chap called Mike Venard, which I know he used to be in a large group. He's gone solo, but it's the song is Still Operating, and I think of this as a testament to me. I'm still going. I'm still operating. You know, he didn't quite mean it like that, but that's how I took it. It's a lot harder than it looks actually. These guys cheated and picked up the floor switches and started squeezing them out. It's easier than that.
How much is a reel of one of those LEDs?
It depends where you buy it from, but about 35 quid.
Yeah.
4 metres. In the plastic waterproof tube.
Yes. Yeah.
It drops about £5 or £6 when you get it without the waterproof tube.
a bit quick, Mike. What was that cost?
35 for that strip. If you get it cheap, okay, you can pay up to 60, 70 quid for 4 metres of it if you want to buy it from this country. But I got them from China. And finally, I want to show you something that my wife referred to as that project. Hated it. And writing for a magazine, like I used to for the micro user, you live in a time warp. So in July, I started working on the Halloween project because I wanted to do something Halloween. There's a part works out 3 or 4 years ago where you built a skeleton over the years, and like all part works, the first one's £1, and the second one's £2.50, and then it goes up to £5-6 for forever. But in the first 2, I could get a skull and a jawbone at the top of the head and some eyes. And what I did was I made a skull, and because it had all the bits coming out of it while I was making it, and when you were going to look at it, go, oh, it's horrible. So I had to keep it with a cloth bag over its head whilst I worked on it. So I produced this, and it did work quite well. I had a servo for each eye, so I changed it. The eyes didn't normally move, so I had to re-drill the eyes and put them on vertical axes and wire a servo up to them. I wired a servo up to the jaw, so the jaw would open, and I wired a servo on the neck so it could move its head. And then I had lots of RGB LEDs that lit up various parts of it. It was very nice. Well, I drilled a hole in its nasal cavity. The nose would light up, and one behind each eye, so the eyes could light up, and a couple of white ones in the skull, so that the skull could come up. So the thing is, and I called it Mulder because Scully would be far too.
Yes. Very good. Yeah.
I did put in the article that if any youngsters here want to know why it's called Mulder, then just ask your dad.
It's a new series.
I know.
Yeah, that's right. Yeah.
Yes, that was in there. So we'll have this. We'll have this to fit the screen. I think. To fit the screen. To fit the screen.
Good grief.
Oops, it's a wrap.
Your body.
That teddy bear in Babbage,
Oh,
which is the mascot of the Raspberry Pi,
Right.
and I won a Babbage in a past the parcel. That one, the Raspberry Pi bashes, so I finished it off with him, sort of chewing me down on it. But what she didn't like was, first of all, was the eyes going and the jaw,
Yeah.
but then all the wires coming out of the skull.
That's wrong.
I hope she didn't tell any of her friends about this.
No, no friends at all at the stage. I missed the opportunity. What we've got at the new house is a porch, but I missed the opportunity on Halloween to actually put it in the porch because it was at the other house.
Oh.
So next year it's definitely going to sort of
Yeah.
look at people.
Looking
Don't
around.
need to buy any sweets.
You will be reported to the police.
And the other thing I want to do with it for the exhibitions, which I haven't done yet, is to fix a camera up that has facial recognition on it,
Right.
so that it will track you. You should walk past the stand. So I'm quite looking forward to that. So, I think that wraps it up. I'd like to say thank you for listening.
Thank you.
Rock, helping you with Acorn and Riscos computing.